Hi everyone, this is a video just to help you with your project in regards to designing the closed end road around here, what we called it TAFE court. Simply, this is a closed end road here, so for the cars to go in, there's allotment would be designed around this area. It's enough space, we make it a round end at the end here to give enough space for cars to do a U-turn and come out. Simply these type of closed end roads, we call them Cul De Sac end or Cul De Sac road. It's a French background name, so regardless, for the design of the Cul De Sac, simply we have to start designing the outer edge of the Cul De Sac. Before I go any further, just to let you know, at this stage you should have finished your design of the main roads, the intersections. I've designed the main roads, created the corridors, designed the intersections between the main roads. I've got 1, 2, 3 intersections that has been designed. Around this area here, I didn't design any corridor. I only have the alignment and the profile of the small road here, TAFE court, and I don't have any corridor. We don't need a corridor there, it's too short to create a corridor. What we will need only to extend the corridor of the intersection and the new corridor we will create around this area by joining the two corridors that will cover all this area here. Okay, to start with, first what we have to do, we have to refine the shape of the Cul De Sac. Simply, this is a rough drawing for the Cul De Sac here. The actual drawing for the Cul De Sac should be smoother around this corner here, and the same thing for that corner. I'll show you the final design. Simply, that's the shape of the Cul De Sac. As you can see, the edges here are smoother. We don't have a sharp connection between the line and the curve around here, the Cul De Sac. So to go back to our file, simply to start with, we have to draw that shape because we will use that shape as our alignment. Overall, just for you to know, the design we'll be carrying is very similar to the design of the curve return around the intersection. We'll create an alignment around this line here on the outside. That alignment will create a profile for it, and we'll use a cross section similar to the curve return cross section. One of those goes around that alignment, going around and along this alignment here. That will create the surface of the Cul De Sac. Okay, so going back to our file, simply the first thing we need to create that shape. Before I start working anything on the Cul De Sac, even, I've got one step to do. Just looking at the size, I'm not sure if you had the chance to notice that. Looking at the size of the road here I gave you, that road is about 5 meters narrower than the other roads. It's just a secondary road, so it's about 10 meters wide, whereas all the main roads here we've got, it's about 15 meters wide. So if I measure the width of the road, it's 10 meters wide. So I simply, to start with, we have to adjust our intersection here to account for that. Simply, all these cross sections here, you can see the lines for the cross sections, has to be narrowed down to meet the 10 meters width rather than 15 meters wide. So first of all, we have to create another cross section. So let's copy our main assembly. Go to copy. We'll call this one assembly 2, that one assembly 1. We work on everything, so let's call this one assembly 2 general, and let's start modifying assembly 2. So assembly first, we have to narrow this. This is 15 meters again. If I measure this assembly from outer boundary all the way to the other side, this is 15 meters wide. We have to make it 10 meters wide. We start with, so we have to take from each side 2.5 meters. I've got 1.5 here. We can get rid of that boulevard area. We've got that 300 we can get rid of, and that 1500 wide sidewalk, we can make it 1 meter sidewalk. So we already got 1.5 meters and plus 300, that's 1.8. We can take 500 of the sidewalk, that will make it 2.3. We still need another 200. We can take it from the lane. We can make the lane 3.4 rather than 3.6. So let's do that. We'll go to this assembly here and that assembly, both of them. I'll make the inside boulevard 0 and the sidewalk 1 meter and the outside boulevard 0. Now notice that the daylight disconnected from the sidewalk. Just make sure that you reconnect that just by clicking on the end of the boulevard with that grip point. Just make sure you grab it to the end of the sidewalk. So as we agreed, we still need another 200, so I'll select the 2 lanes and make them 3.4 meters wide rather than 3.6. So now looking at our measurements of assembly 2, adjusting the measurement to the outer edge of it, it's 10 meters wide. Okay, great. Since we're here, let's create the curb returns. We will need them. Let's create left hand side and right hand side. We don't know yet which one we'll need. Let's create them both. So I'll copy this once and twice. For the first one, I'll create left hand side. So I'll delete the left hand lane and the right hand curb and daylight and sidewalk. Now I'll create the opposite, those and that. Okay, so let's put another circle here for assembly 2. So this is our assembly 2 and the curve returns for assembly 2. Let's name those. So assembly 2 general, I'll call this one assembly 2 curve return right hand side, and this one assembly 2 curve return left hand side. Okay, now let's go back here. First of all, we need to, as we agreed, narrow this area here by 5 meters, 2.5 each side. So I start with, I need to go to the intersection that we designed and change the offsets on the side road only. So currently I have offsets of 3.6 of the main road, the primary road and the secondary road. Now for the secondary road, we agreed we made those 3.4, so that will be 3.4 both sides. Got that done. As you can see here, the side road assembly being narrowed down. Now what we need to create a region, so we can change, I have to create a new region around here on the corridor, so I can change the cross section for that corridor. So to do that, split region, I need to split this region here, and I'll split it just around here, and I'll split that region just around here. Okay, so now I created these new 2 regions where actually I'll move that new region boundary a bit further all the way outside the parcel here. Okay, so what we need now to add the new cross sections into these 2 new regions. So I'll just go to region property. This region here, I need to change that to, rather than assembly 1 right hand side, I'll go to assembly 2 right hand side, the narrow assembly, and I'll do the same thing for that. Okay, let's update our corridors. Alright, so we've got a transition area here between the 2, as you can see on the daylight, between the 2 regions, which is fine. We can detail this later on down the track if we need to. It's not very important, but if we want to, we can do that. But as you can see here, the cross section is narrower, So we've got the lane 3.4 and we've got the curb, and then we have a 1 meter sidewalk, finishes exactly with the boundary of the parcel. Okay, so that's our first step done. Now our next step to change the shape as we agreed to the outer side of the Cul De Sac. So let's hide our corridor, hide objects, and let's work with the outer side of this parcel here. So let's just draw a polyline simply. That polyline, let's draw it from, I need to start and end at the same location. So first of all, maybe it's just a good idea, let's draw a line from here to there, perpendicular to that. So this will mark our start and end to make it a defined start and end. It's very important, if you notice here, this is the edge of my corridor. It's important to overlap the two corridors together, and you'll see why. Because we will need a reference. Where's our levels? We will take those from our corridor here. So we start drawing our outer line. Shift right click in point from here and turn off the auto. So that will go to a certain point there. So rather than doing that, I'll keep the snap on. So I'll get to a point somewhere here. It doesn't have to be really super accurate. It's all about just creating a nice smooth transition between the two areas. That's my second point. Now for the third point, rather than drawing a line going here, if you press A, enter, while you have your polyline command still on, that will change your line to an arc. So that way we can create an arc. So we'll go all the way here, about roughly the same distance, and then we'll create another arc all the way to here. We'll fix that in a second, the outer side of it, and another one here. Then to change back to line, we'll go L, enter. So simply we started with a line, we changed to an arc around here, we draw another arc here, a third arc, and then we went back to a line. So we need that to finish about here. Enter. So now let's fix our polyline that we just drawn. First we'll bring this one here and make this one suitable for the curve. Turn off the snap, make it easier. That's all we're after, just a smooth transition between the two. The larger you make the arcs, the smoother they will be. That looks good to me. Okay, so I'll delete this first polyline. Now looking at this is the new polyline that we just drawn, but that's not where our alignment should go. If you remember, for these lines here, that's where our alignment was going for the intersection. So our alignment should go in line with this, should go all the way here on the inside, turning around to draw a curve all around and then come match that existing curve. So all I need to offset this line by the same distance, and that distance should be, if you look at our cross sections here, it's the distance from this line here all the way to that line there. So if I measure that distance from here to there, it's 1.6 meters. So let's double check that. If I measure that distance here, that's 1.6 meters. So I'll select the polyline that we just drawn now, and I'll go to offset 1.6 to the inside and enter. All what we did so far, we just created the outer line, we offsetted that by 1.6 to create a polyline continuing the curve returns. We are trying to create another one of those alignments, continuing all the way inside the Cul De Sac, turning around and coming to the other end. It's always easier to work with polylines to start with, kind of sketch your design, and then start refining your design to an alignment and profile and the rest of it. So for now we don't need this outer one, but we will keep it because this will be the outer side from now on for our road. So simply I'll just trim everything to it, which is not very important, it's just cosmetic work, just to make things look nicer. And I'll delete that. Okay, unhiding everything, unhide. We're finished with the sketch work. So we've got everything back in place. Okay, so we created the alignment, or we created a polyline where the alignment should go. Now we have to convert this to an alignment. So I can just select that polyline. I'll go to alignment, create an alignment from an object. And this is obviously selected. I'll select the object again. You can see a small arrow here showing me, is this the direction you want for your alignment? I'll accept that because I know in my curve return design I've got the direction going this way and that way, so I'll accept that. It doesn't matter really, it doesn't have to match any of these directions, but it's important to know your direction. So by knowing the direction, as we agreed, I will know which assembly to use. Knowing the direction going this way, that means I have to, if I am driving along this alignment, I have to choose a cross section where I have the lane on the left hand side and the sidewalk and daylight on the right hand side, so the right hand side assembly. So I'll accept that direction, enter, ask me what's the name of the alignment. We'll call it Cul De Sac, CDS, and I've got everything on site 1. You don't have to have them on a site, but I've got them already on site 1, so I'll maintain that. I don't need to add a curve for this alignment, and I don't need any labels for it. And I'll ask for erasing the existing entity, which is the polyline we're creating it from. Press OK. So that simply just convert this polyline into an alignment. Okay, so this is not a polyline anymore, it's an alignment. Now if I draw a surface profile to this alignment, I'll go inside profile, create surface profile for the Cul De Sac, the new alignment I just created from start to end all the way using the existing surface. I'll add that and draw in a profile view, and all of those I'll keep them the standard, and I'll just add the profile here. Simply this is the existing surface along the curved line. Very important to understand, this is a curved line profile, so it's not the road. The road goes just like that, but this is where the curve is going to go, around the edge of the Cul De Sac. The reason I'm saying this is the curved line, so I don't have to follow the road design rules about the K values, about the size of the curve and all of this. This is a small road, there's no worries about the K values, about the radiuses and the size of the curves, or the curves. Okay, so we created an alignment, we have the surface profile for that. Our next step to draw a profile for that alignment here. In other words, I have to start designing the elevation or the height of these curves, where they sit in relation to the existing ground and in relation to the existing corridor I've got here. So to be able to know where to start and end, so I can match the curve start and end elevation, I have to project these heights into my profile view here. So to do that, I'll create the surface for this corridor. So corridor surface, I'll create a new surface for the top of the corridor, and I'll apply the boundary. Don't forget to apply the boundary. I've seen many students, they do forget that. Just created the surface here. Now after we created the surface for that, what we can do by clicking on the alignment that we had here on the curve, I can just go surface profile, add that surface to my profile view. Just an information. If I go to my profile view, this is what we're trying to say. Simply that told me now where the existing corridor surface sitting. So that means that's telling me where I start my curve line, this is the height of the existing curve, and when I get back after I do the U-turn here, after I do the U-turn and come back here, this is the height of the curve. So I have a start and end point to work with. So what we can do now, create a profile for that. So if I go back to profile creation tool for this profile view, and we'll call it Cul De Sac proposed as usual, proposed profile, Cul De Sac. Go OK. I don't need the labels for that, as we agreed. There's not too much concerns about that. This is a profile of a curved line, not a road design. So I'll draw a tangent with curves. Very important to start from the same point where the existing curve is. So I'll click to that. I'll turn the snap off. I'll try to go in line with that. Then I'll try to go as close as possible to the surface. In point, enter. So I've got a very small curve here. I have to fix it simply by just clicking on the as we agreed. I'm not concerned about the size of these curves or the K value. This is around the curve area, so it shouldn't be a problem for the heights. That's good enough. We'll close that. Now we have a profile, we have an alignment, we are ready to create a corridor, and we have a cross section. So to create a corridor, create a new corridor. As usual, very important to tick the 4 different requirements there. So Cul De Sac alignment, proposed profile of the Cul De Sac, and the assembly of, as we agreed, assembly to curve return right hand side, and daylight to the existing surface. Press OK. Let's change our frequency to 1. Go OK, and as usual, when I press OK, we'll get lots of errors, but that's fine. We'll fix those as we go. Now, looking at this corridor here, the usual thing what we've done around the intersection, our next step to start fixing our targets. That's why, by the way, we overlapped the 2 corridors, so we can get these 2 guidance or reference levels into our profile here. Now what we can do after we finish that, we can start shifting them just to end to each other. Now first of all, let's fix our targets. So let's go to this region. Our surface target is the existing. Our width target should be, let's think about it, what's our width target here? I'll click. Should all these cross section go to one line? They should all try to reach this line here, which is alignment of the TAFE chords, and obviously its own profile. So by selecting that line, that added the TAFE chord alignment. Go OK, and the same thing for the profile. I'll look for the TAFE chords profile, design profile, and I'll go OK. We are familiar with those, shouldn't be very concerned at this stage. I'll just clear them for now, and we'll see if they continue to appear. Okay, so that's the design is done for the Cul De Sac roughly. Now if you look at that, you have that small green line here. Simply that's an area where it doesn't have targets because you've got some cross section. For example, this cross section here doesn't reach that alignment. So if you have small areas, I'll just exaggerate that error a bit for you so you can see. Right click, display order, center back. This is my alignment here. If my alignment is slightly to the back, let's assume it's here, and let's refresh our corridor or rebuild it. Rebuild automatic. If you have some errors like that, you've got large areas or small random shapes that they don't match in the center simply because your alignment doesn't reach enough distance for all the cross sections to target that alignment. So what you can do, and that's something we usually do around the Cul De Sac only, you can just simply stretch that Cul De Sac further within the area of your design. That will make all the intersection finishes to that Cul De Sac. So that's the design of the Cul De Sac. If you guys have any issues with it, we can discuss tomorrow or the next day on Wednesday.